All right, so today we're going to be here in chapter 24 of our McGraw-Hill Connect textbook, looking at the homework assignment. And in 24, we're looking primarily at some finance topics and some capital budgeting type issues. And so we're just going to go ahead and hop right on in. You'll notice this assignment quite a bit shorter than some of the other ones, just in terms of the number of questions. We've only got 7 questions for this one. So it shouldn't take us too long to get through it, but we are going to take it nice and slow, like always, to try to make sure we understand exactly what's happening at each step in the process. So here we go with our first question. Number 1, we're looking at payback period when we have uneven cash flows. So the key here is this word uneven. If we had even cash flows, then this is quite a bit easier, because then I can just take the actual cost of the investment, or the amount of the investment, divide that by the annual cash flow, and that would give me the number of years of the payback period that we actually need. But in this case, that annual cash flow is not the same each year, so we can't quite do that. So we have to try to figure out what the actual changes are going to be because of that. And so what we notice here is, in this case, we have Bayer Company, who's considering the purchase of an asset for $200,000, which is expected to produce the following net cash flows. The cash flows occur evenly within each year. So what we want to see first is that in the beginning, we're going to refer to this right here as year 0. This is the initial outflow. And if you want to kind of link that 0 with like the letter O, right, you can. So in year 0, that's where we have an outflow. What that means is this is requiring the actual payment of cash at that point in time. So our cash will be going out. So this will get denoted as a negative. That's why that's in those parentheses, is indicating that this is actually an outflow of cash. Now, at the end of year 0, right, the day we actually make that investment, in other words, we've not earned any cash to offset that initial outflow. So my cumulative outflow is still just the $200,000, which is still in parentheses. Now, after the end of the first year, we get $50,000. So we'll generate that 50 right here. And now our outflow in total is just going to be the 200,000 that it was before, plus the 50,000. And so what we see is we're still negative, but notice that now we are only negative by $150,000. So we're moving in the right direction, because what we want when we're looking at payback is to find the point where this cumulative net cash inflow or outflow equals 0. That's what we're after, is finding where that goes to 0, because at that point we will have gotten our cash back. So in this case, we're just going to continue down. Notice in year 2, we get 32,000. So that drops right here. 150 plus negative 150 plus 32 is negative 118. And we're just going to continue down. Now you'll notice something happens here between years 3 and 4. So let's look at what happened right here in this area. So in year 3, notice my cumulative net outflow, or my cash position, is still an outflow at the end of year 3. But by the end of year 4, we actually do have positive cash. So we actually generated an inflow, which means somewhere between that negative 57 and positive 93 is the 0 that we're actually looking for. And so what we need to do now is figure out how much into that actual 4th year we will need to go to hit this 0. So what we want to notice first is that payback occurs at a minimum of 3 years. So it took us 3 full years plus, but then we have some portion of year 4. Now it's not going to be enough for us to just say, oh, okay, it was about 3 years. No, we want that fraction. And so what we need to realize is that the cash flows occur evenly within the year, which will always be the case in my course, at least. If this isn't the case, then it's not much more difficult. It just adds a few extra steps where you have to actually partition that revenue out by month or by quarter over the course of the year so that you actually reflect the cash flows. For a principles class, I think that's a little bit just too down in the weeds, so I don't want to take us to that point. So we'll pretty much keep it where the cash flows occur evenly within the year. And so that's what we're going to see. But what that means is we need to generate $57,000 worth of cash flows in that next year, in year 4, and year 4 generates a total of $150,000. Because we know that cash is coming in evenly throughout the year, what we know is that it will take 57/150ths of the year to actually get that revenue, or not the revenue, but to get that cash flow generation that we're looking for. When you do that, this comes out to 0.38. So your total payback period then is 3 years plus 0.38 years, giving you a total here of 3.38 years. Now, what I see is the most common mistake on something like this on a test. Very commonly, students will come in and they will do beautiful work for me all through a lot of this. So they'll get this, they'll get that, they'll get this, this, and they'll do this whole table pretty much right. And so they'll get most of the points. And then they'll come down and they'll even do this right. But then at the end, when I ask them for the actual payback period, they'll tell me, oh, it's just 0.38 years. But you know that's not true, because you knew before you even started dealing with that fraction, 3 years were required. Don't forget about the full years because you get so focused on the partial year. Does that make sense? Okay, well, very good. So with that done, we'll go ahead, we'll hop on over to number 2. So that takes us through the end of number 1 and now into number 2. Now, number 2. We're looking here once again at payback period, but notice this time with accelerated depreciation. So remember, in Accounting 2301, we had basically, we had more than this, but we had at least 2 types of depreciation. We had straight line depreciation, which we said was just equal to cost minus salvage. Let me get my parentheses working here just to be clear. So that's on top, divided by estimated life. Then we multiplied that by the number of months we owned the asset during the year, over 12. So this was our formula for straight line depreciation. And that's fine. But in this case, they're asking me about accelerated depreciation, specifically double declining depreciation. So whenever we talk about double declining, remember our formula for that. And there's 2 ways you can write this. This is the way I write it, is 1 over life times 2. That'll get you that ratio that you need. So notice the big difference here for double declining so far is we don't care, at least at first, about the cost or the salvage value, right? We're just getting a rate at first. So this 1 over life, that's actually your straight line rate. Then you're multiplying it by 2, hence the name double. So double declining, we're going to get the rate for straight line, then multiply that by 2. And so we get double declining, but then we have to actually multiply all of that. And really, I'm just doing the parentheses here, not because you need them. I mean, it would be fine without them, I believe. But mostly so you can see, all right, this is step 1. Then we're going to multiply that by my beginning of year book value. By my beginning of year book value. And that will actually give me my depreciation expense for that year. Now, that's helpful, but now that begs the question, and some of us might have forgotten, especially if it's been a minute since you did Accounting 2301, what the heck is book value? You say, I don't know what that is. So let's remind ourselves. Well, we remember from 2301 that if we take cost minus accumulated depreciation, that actually gives us this idea of book value. And the reason this is so important is, I'll just do a quick little mini depreciation example here for you. I'll assume something like straight line, just so it's easier to mock this up really quick. But what we want to see is we've got our cost, we've got our depreciation expense, we've got our accumulated depreciation, and our book value. And so if we were to look at this, and we did this over, say, a couple of years, and actually, I'm going to pull up an Excel spreadsheet real quick. It'll just be much easier to show you this in Excel. And since I've got the whole screen shared, it should work perfectly fine. This is how I'll normally do this, is with Excel whenever I'm teaching this. All right, So what we want is we're just going to set up here year 1, year 2, year 3, and year 4. We'll come over here, we'll have our cost, we'll have our accumulated depreciation, our book value, and then I'll do depreciation expense just kind of down the way just to separate this out some. What I want you to realize is, let's assume we had a situation where we have a cost of $100,000. We have a life of 10 years and we have no salvage. So no salvage. Get us a little bit extra room here. Salvage is 0. Now, our cost, of course, this is just going to be our cost. And that's going to be the case in all 4 years because it has to be. Remember, we have this whole thing called the historical cost principle that says we don't get to change the cost. The cost is the cost. Now, the depreciation expense, and to be fair, right, this is a 10-year life. We're not going to hit the end of this. But we can look at least the first couple of years and see what's happening. And so what we find is that the depreciation expense piece, well, this is just going to be my cost minus my salvage divided by my life. And if we assume we bought this at the beginning of the year, oh, I forgot. There we go. What we find here is that we end up with depreciation expense of $10,000. And what we'll actually know about this is that this is going to be the same in each of my years because it has to be. Depreciation expense under straight line is the same in each year. The only way that gets messed up is if you buy the thing in the middle of the year or sell it in the middle of the year and you have a partial year piece. But other than that, it's going to be the same all the way across. But at the end of the first year, my accumulated depreciation, well, I've accumulated 1 year's worth of depreciation. This is just equal to the current depreciation expense. But in year 2, this is going to be equal to the sum of the current year's depreciation and the prior year's depreciation. And then this in year 3 will equal the sum of the current and all prior year's depreciation. And in year 4, the same thing. And so what we find is that over time, notice the change. Your accumulated depreciation is doing what it says. It is actually accumulating over time and increasing, while your depreciation expense, at least under a straight line method, is coming through at the same amount each year. The reason this happens is, remember from 2301, at the end of each year, we actually close those temporary accounts. Depreciation expense, being an expense, is one of the things that gets closed. And so it actually gets closed out into retained earnings. And so we have that depreciation expense go back to 0, where we can then record the next year's depreciation expense, and it just repeats itself each year. But that accumulated depreciation is what we call the Contra asset account, which is a permanent account, which means it pairs with its buddy, in this case, the actual equipment or the plane or the whatever, the building, whatever your asset is, and it works to actually reduce that over time. And then, of course, you'll see here that this is equal to this minus that. And what's happening over this period is your book value is certainly coming down. So book value is this. It's the difference between cost and accumulated depreciation, and notice how it's changing each year. So with all of that kind of recapped in mind, because I know for a lot of us, it may have been a minute since we did anything with depreciation, we can go ahead and hop back over to our actual problem and see how it works with these facts and with double declining balance. So in this case, the machine will be purchased for $290, used for 5 years, yields the following net incomes. And projecting net incomes, double declining depreciation is applied. Now, this is important, no salvage, all that. But what I want you to realize is, or what I want you to think about is, what is the difference between net income and cash flow? So net income includes things that are revenues, expenses, gains, and losses. And some of those things may or may not include cash. So net income, I'm just going to really simplify this. It's just revenue minus expense. Truthfully, there are other things, right? We know that. But just for this, I want you to get kind of a broad overview. But out of our expenses, there's one that is never a cash expense. And that non-cash expense that we really want to focus on is depreciation. Remember, depreciation is just the systematic devaluation of your asset over its useful life. So you're not actually writing a check to anyone whenever you're dealing with your depreciation. This is just a book thing, right? It's a book thing. It's a book devaluation to show that, hey, this asset is not worth as much as it used to be worth. And so it affects income, but it doesn't affect cash, which means that when they give me my net income, but I'm being asked about payback, I've got to figure out a way to go from net income to cash flow effect. And what we've decided then, based on our discussion, is that net income subtracts depreciation, even though depreciation does not affect cash. So if I want to go from net income to cash flow, for my cash flow, I will need to actually add back the depreciation expense. So I'll come in other words, what we'll do is we'll take net income plus depreciation expense, and that will get me to my cash flow. This is what we're going to have to do. We're going to have to do it several times as we walk through this problem. So here we go. I'm going to go ahead. I'm going to wipe out the majority of this stuff just so we have some room to actually do the work. But here we go. All right. Now, I'll leave our big formulas up top because it might be helpful for you to be able to see those. But other than that, we're going to go ahead and hop back in. So at the beginning of year one, well, I will need to figure out what my book value is. Well, remember, book value is cost minus accumulated depreciation. That gives me book value. And I certainly know my cost. It's this. And at the beginning of the first year, I've incurred 0 depreciation expense. So my accumulated depreciation is also just 0. So I have 290 minus 0 is 290. That's where this comes from. Now, what we then need to realize is that we need to get our rate. So in this case, 1 divided by 5 times 2. This is 0.4. That is where this 0.4 comes from, or that 40%. It's coming from this computation right here. Goodness gracious. Now, all we're going to do to get this accumulated depreciation at the end of the year, you're going to take your 290, multiply that by 0.4, and you'll get 116. Now, at your ending book value of year one, you'll have 290 minus 116. That'll give you 174. That will be your ending book value for year one. But like we've seen time and again in this class, and some at least also in 2301, what you end one period with, you begin the next period with. So we'll now take our 174 from right here, bring it down to be my beginning book value for the next period. I'll repeat the process. 174 times 0.4, that comes out to be 69,600. Then for my accumulated depreciation, I'll simply add my 116 plus my 69,600, gives me 185,600. Then, as we know, my cost is not changing, so my cost is still 290, but my accumulated depreciation is now changing to be 185,600. And that brings me down to a new book value here of 104,400. And with this in mind, I'm not going to go through the rest of this. You're just going to continue down. But notice what happens here in the last year. I will stop for a second and point this out. Notice we'll continue doing this 0.4 thing all the way through until the last year. Notice what's happening in the last year. 40% of 37,584 is certainly not 37,584. It's something else. But the reason this had to be 37,584 is at the end of any asset's useful life, its book value must equal its salvage value. Well, in this case, our salvage value is 0. Because it was 0, this had to be 0 by the end. So you kind of solve this last row backwards, by setting this equal to salvage in this case, which is 0. And then you say, well, for that to happen, my accumulated depreciation needs to be 290, the same as my cost. Then to get my accumulated depreciation to 290, when it's currently at 252, that means I'll need that difference, 37,584, in annual depreciation for year 5. So that's how we're solving this one. Okay, so I'm going to go ahead. We're going to erase a good bit of this one more time, get us some more space, and then we'll continue down. Now, for the next part, we're just looking at the cash flow implications. So for the cash flow implications here, this part, not too bad. Once you've done all the depreciation and gotten all that set up, all you're doing now is coming in. You're going to take your actual net income that you were given, 20,000, put it right there. Take your year 1 depreciation, 116, put it right there. Add those two up. That gives me my net cash flow. And then, of course, your year 0. Well, in that case, you spent that full 290. So that was a negative out. That was an outflow in year 0 for 290. Negative 290 plus 136 is negative 154. You'll come down year 2. You got $34,000. 34 comes in right here, plus the 69,600. That'll give you your new cash flow effect of 1036. Netting that against the 154 brings you down to here, and we'll continue down. Now, the part you want to pay attention to in this table, and it may be in a different location on yours, but what you're looking for, once again, is where you have this switch from negative to positive. Wherever that switch occurs is where we want to zone in on or zoom in on. So in this case, you're going to take that 50,400 that you still need to recover, divide it by the 103,760 in cash flow that you'll get in that next year, and that will give you 0.486 for the partial year. To that, of course, you will need to add the full 2 years that you already knew about. So you'll go ahead, do that. 2 plus 0.486 is 2.486 years, and that gets you your payback. And as we discussed in class, payback has a ton of limitations and shortcomings. If you're making your decisions purely on the basis of payback, period, it's very likely that you're making poor decisions. And so because of that, we've got several other methods that we're going to continue to look at as we get further into this assignment. Now, for the next one, this is a payback period problem that is super simple, right? We have one in here for even cash flows just so you can see how it works. But you'll notice this one's much easier. So in this case, a new operating system for machine costs $240, has a useful life of 5. System yields an incremental after-tax income of $69,230 after deducting straight-line depreciation. Predicted salvage value of the machine is $9,000. And then in B, a machine costs $200, salvage of 13, is expected to last 11 years to generate after-tax income of 38 after straight-line depreciation is taken care of. So a couple of things we're going to have to do here. For the first piece, we're going to come in, and of course, we've got our cost. So for the first one, this is the 240. For the second one, this is the 200. So we'll go ahead, we'll drop those right on in. And then we're going to divide that by, of course, our annual net cash flow, which you'll notice they did not give me. But they did tell me that for A, we have projected net income of $69,230. But notice this is after deducting straight line depreciation. So you say, okay, well, what information do I need for straight line? Well, I need cost, which in this case is 240. I need salvage, which in this case, they told me 9,000. So it'll be 9,000. If you want, you can actually shortcut this and call this or use what's called a depreciable base here. This is how much depreciation you actually can take over the life of the asset, 231,000. This is just doing that subtraction that's going to be on top for our straight line formula anyway. We can just go ahead and do it right now if you want. So this comes out to be 231. Then, of course, we've got our life, and our life is 5 years. When you come in and do that division, 231,000 divided by 5, you'll get 46,200. Add that over here, 46,200. And when you do 69,230 plus 46,200, you will come out to 115,430. which is what we should come out to right there. But that's how you do it. Now I'll do the other one in a different color. So we'll do this in blue. So we've got a $200,000 cost, a $13,000 salvage, gets us down to a depreciable base of 187. And this one has a life of 11 years, so 11 years. And when you do 187,000 divided by 11, you will come out to $17,000. Now for B, we were told we had after-tax income of 38,000. So that's our starting point, plus the income effect of the depreciation of 17. And we get $55,000 in cash flow. And so that's what we wanted, and that's what we get right there. Now at this point, it's just a matter of division, and you're done. So the nice thing about these even cash flow problems is all you got to do is figure out, well, what's the depreciation? Do that, and you're pretty much done, because now it's just a division between the cost of the investment and the annual net cash flow. So with that, we can go ahead. We'll move on to number 4. The number 4 gets into one of our much better methods. Net present value is a method that is very good at discerning profitable projects on their own. It struggles a little bit whenever you're comparing multiple projects. If they're both profitable, it doesn't always do the best job of ranking them within that context, but it is certainly able to deal with one individual project at a time in determining potential profitability. When we get into actually ranking projects, we want to kind of steer away from net present value, and that's where we'll normally use what's called Profitability Index to actually rank different levels of profitable investment, and it will help us allocate our resources more efficiently. But when we're looking at only 1 or 2 projects and we just want to know, is this potentially profitable at all? Net present value does a great job of that, because what net present value does is it says, all right, imagine a timeline where we've got year 0 right here, and we've got year 5 here. Year 4, year 3, year 2, year 1. Probably not exactly evenly spaced, but hopefully it's good enough that you can kind of get the idea. So let's imagine in this case, and I guess we can just use these numbers. Bayer Company is considered the purchase of an asset for $245. So in year 0, we're going to have to spend $245,000. Now, what's the present value of $245,000 that you're spending right now today in the present? Well, hopefully you say, well, it's $245,000. And you're right, it is. So what's nice about this initial outflow is there's no present value computation needed because it's already in the present. So we don't have to move it. So it works out very nicely. But notice what happens. We get $89,000 in cash flow, but that happens at the end of the next year, which means that's not going to be worth as much as $89,000 if we got it today. And there's several reasons for this. The 2 biggest are things like potential inflation and the loss of investment. So if I had the $89,000 today, 1, it wouldn't be hit with inflation today because I'd already have it. But 2, I could take that, invest it in something, and actually earn a return on it. So the loss of that invested return and the compounding of potential inflation leads to the devaluation of this over time. And this effect gets stronger the further away from the initial investment we get. And so what we find is, looking at our table, notice what's happening to our factors down below. As you get further and further away from the initial outflow, those multiples come down and down and down, because $1 is now worth less 2 years than it was 2 years down the road than it is a year down the road, and 10 years down the road than it was 7 years down the road. And so what we're doing is we're taking each one of these and we're bringing them back to time period 0. So the 89 will have to come back 1 period. The 51,000 that we get in year 2, well, that will need to come back 2 periods. The 76,000 that we get in year 3, this will need to be discounted by 3 periods. And so you can see this happening, and I really like the timeline because it makes it very visual for you, where you can see, okay, this is why it's having to travel much further. It's having to go back a much further distance, and so it does matter. So at this point, I'm going to go ahead and erase our timeline just to clear up that space, but hopefully that was a good visual for you to kind of see what's happening. Now, at this point, we've got our situation. Purchase price is $245. Cash flows occur evenly within each year. Assume Bayer requires a 12% return on our investments. So what I want you to realize too is look at these numbers. Are these numbers the same each year? So is 89 the same as 51, the same as 76, the same as no, right? These are different numbers in each year. And so what I'm going to recommend is that you do this with the present value of a lump sum table. This is in your book called Table B.1. If you're using a different book, or if you're not one of my students, it may be certainly titled something else. But in this version of this book is called Table B.1, and it's actually going to be this table that I'll open up here in just a second. But that's the table we're going to go to. It's the present value of a lump sum of $1. Let me get, I guess, the full name in there. If these had all been the same number, then I would recommend that you actually use Table B.3, because B.3 is the annuity table. Which, of course, we know an annuity is just an annual cash payment in the same amount at the same time, et cetera, for an extended period of time. And so in this case, they're not the same, so we can't use the annuity table, which is kind of a shortcut table. Instead, we've got to go through and do this one at a time. So what we're going to do, we're going to go ahead. I'm going to switch over to my regular mouse tool so I can open up my table. And what we were told is that we wanted the discount at 12%. So we're going to come in, we're going to find 12%. That's the column we want to look at. And we were doing this for 5 years. So I'm going to need all 5 of these factors, right? Not just 1 or 2 of them, but I need all 5 of the factors in this region, because I'll need this factor for the cash flow from year 1, this factor for the cash flow from year 2, that factor for the cash flow from year 3, et cetera, so that I'm making sure I'm multiplying these things correctly across. So now if we come back, we should recognize the 0.8929, the 0.7972, all the way down to the 0.5674. And I'll just go back one more time so you can see that. But that's the idea, right? We're coming through, grabbing each one of those factors, dropping them into our table, and then multiplying across. 89 times this factor is this. 51 times that factor is this. And so at the end, we can see that the present value of the cash that we're actually receiving, once we've done all this multiplication and added them all up, is $310,990. And you say, well, that sounds all right. But we got to remember, it cost us something to do this, and it cost us $245. At the end of the day, I'm getting a value of $311,000 for a cost of $245. That seems like a pretty darn good deal to me. So our decision rule when we're dealing with net present value is if net present value is greater than 0, we invest. If it is less than 0, we don't. Okay, that's our decision rule. When we're dealing with net present value, especially with one project, as I said, if you're ranking multiple projects, if you've got a capital rationing decision that you're having to make, net present value may not be the method you want to use. In fact, it's not the one I would recommend for that. But if you're looking at one individual project, this is the decision rule. If net present value greater than 0, do the thing. If it's not, don't do the thing. Now, for requirement B, we just are asked, should we accept? And of course, because 66,000 is positive in this case, and that is, of course, greater than 0, we look at our rule, we say, yes, we should invest. And that is the decision that we do want to make in requirement number 2. Now, had this come out to be negative 6,000, don't do it, right? Don't make that investment. Now, number 5, we're going to start combining a couple of things. We got another payback problem, and this one's going to be tied in with accounting rate of return. So, and you'll notice kind of as we go through the next couple, the next one's got NPV and profitability index. The next one's got another NPV and internal rate of return. So these last couple just kind of pull a lot of the things that we've been doing so far into combination problems, which are always a lot of fun. So in this case, B2B company is considering the purchase of equipment that would allow the company to add a new product to its line. The equipment is expected to cost $120,000, 12-year life, no salvage. So if I'm looking at this, I'm probably just going to start writing some stuff down. Cost 120, salvage equals 0. So depreciable base is 120. Life, 12 years. Okay. It's depreciated straight line, so I can just divide that by 12. I'll get $10,000 per year. And this is my depreciation, my straight line depreciation. The company expects to sell 48,000 units of the equipment's product each year. The expected annual net income is below. So we see all that. It's all given to me. And what we want to realize is the payback period here should be able to be done in about 3 seconds once you've got your depreciation, because we know the cost. Cost is 120, so drop that in. We know our annual net cash flow because at this point we recognize that my cash flow is simply equal to my net income plus my depreciation expense. Well, because we're using straight line, that's going to be the same in each year, so 10,000. And they told me we expect these results each year. So that's 10,500. So my total here is 20,500. Drop that in right there. And then you just do your division and you've got your payback period complete. So hopefully the payback on this one wasn't too difficult. Probably the easiest payback problem that we've seen on this homework assignment, truthfully. And at this point, hopefully we're comfortable enough that we were able to crank that one out pretty quickly. For requirement number 2, though, this is one that we haven't done yet. So we haven't dealt with accounting rate of return. So the formula for this one is just going to be our annual after-tax net income divided by our annual average investment. Now, the annual average investment is the piece that people mess up more often than not. And I'm going to show you how to do it, even though in this case, it's a little bit easier because there is no salvage. But what I want you to think about is, what if I were to ask you for something like average inventory? So if I said, how do you compute average inventory for a company? Well, you would say, hopefully, right? You're going to take their beginning inventory. You're going to add their ending inventory. And you're going to divide that by 2. And I'd say, yeah, that's exactly right. And so students really struggle with annual average investment because it sounds so fancy and so complicated. And we think, oh my gosh, this has got to be something really nasty. But no, it's just an average like any other average. So what we're going to do is, for my annual average investment, and I'll just call that my annual average investment, AAI, just because I don't feel like writing the whole thing. We're going to come in, we're going to take our beginning value of the actual asset, which, let me give you a hint here, is just the cost. It's the cost. So we'll just write that. Cost plus my ending book value for my asset. And what's the more general way to write my ending book value other than just calling it that? Because that still feels like I'm going to have to do some math if I have to find the ending book value of an asset. And what if I gave you a question that said, very unrealistic question, certainly, but a good test question. ABC company is looking at buying a product with a 13,614 year life. Well, if you're going to sit here and try to crank out 13,000 years worth of depreciation, you're never going to finish by hand, right? I mean, certainly not within the amount of time you would need on an exam. So you've got to realize there's a link here that we should be able to pick up on, which is that my ending book value is always equal to my salvage value. So just like my beginning inventory balance was where we started with inventory, with my annual average investment, we're going to start with my beginning book value. Then I'm going to add my ending book value, which I can just call my salvage value. And once again, it's an average of 2 things. So divide that by 2. So cost plus salvage over 2. Well, in this case, my cost is 120. My salvage is 0. Divided by 2. This is just 60,000. There we go. That's where the 60 comes from. The reason I wanted to show you all that explanation to the side is, in this case, you had no salvage. But if this had said you had a $20,000 salvage value, this right here would have changed to be 120 plus 20 over 2, which would be 70. Then this would be 70,000. Does that make sense? So I don't want you to think, oh, okay, it's just take cost divided by 2. No, in this case, that worked because there was no salvage. But had there been a salvage value, you would have needed to consider that. You would have absolutely needed to consider that. Okay. Now, At that point, you're done. You're just going to do that division, and it actually looks like it does it for you. So then you're finished. Now, the big pull or the big reason people like accounting rate of return is it does give us a percentage measurement. Unfortunately, like your payback period, though, it does ignore time value of money, which is not always great. And so it has certainly some limitations, but we do typically like to make decisions based on percentages rather than absolutes. Because if we've got projects of two wildly different sizes, it's much easier to compare them by percentage where it kind of normalizes them than comparing them like this, where it looks like this project is much better, but it costs astronomically more also. We kind of lose that in looking perhaps at just the bigger cash flow or the bigger net income number, and we forget just how much more it's costing me. Percentages have this nice way of normalizing comparisons. So we really do like those. They do a great job for us. So that's why this method does get used for accounting rate of return, even though it does ignore time value of money, just like payback period. It has some strengths to it as well. All right, number 6, net present value and profitability index. So we've seen a net present value problem before. So that part of this problem should not be anything we're too unfamiliar with. But the profitability index part might be, right? So we're going to go through both pieces, but hopefully this first part isn't too difficult for us. Now, what I want you to realize is that in this case, we've got two potential projects. We've got a project A and we've got a project B. Notice they have two different costs and their cash flows are certainly wildly different year over year. So here we go. What we're going to do, we're going to try to figure out which project we should actually accept. So for each project, compute NPV, then determine profitability index. Then if they are mutually exclusive, which one should you pick? So what I want you to think of whenever you think of like mutually exclusive, what I always think of is, because I used to mow a lot of yards whenever I was in high school and in college, I would buy me like a push mower and a weed eater and all this kind of stuff so that I could do that. Well, whenever you are looking at buying a push mower, for example, or a riding mower, whatever type of mower you want, once you find one you like, you don't need another push mower if it's just you or another mower, right? Because you've got one person, you, and you've got one piece of equipment that you can use at a time. So it doesn't do you any good to buy a second or a third or a fourth mower because you can only use one at a time. However, buying the mower does not preclude me from needing the weed eater, right? I need both pieces. Those are two very different things. They are not mutually exclusive. I can actually have both and it still be a good investment. But in this case, they're asking us, well, what if essentially project A is one push mower and project B is another, right? Now, certainly these cash flows and things are much higher than that, but hopefully this brings it down to an example that's a little bit easier to understand what we're looking at, right? We're looking at two similar things that do basically the same thing, and we're trying to figure out which one is the better choice. So here we go. In the first case, we are told that we have our initial investment of 181, and then we have our cash inflows. So if we go up, of course, all this is this right here, 50, 53, 86, 85, and 60. Those just drop straight in right below, right there. And then all we need now are my present value factors. And they tell us, in this case, the company requires a 6% return from its investments. Once again, these are not the same numbers. So we're going to have to come in, we're going to use our present value of a lump sum of $1. We're going to come over to 6%, and we're going to go and grab these 5 values, 0.9434, 0.8900, 0.8396, etc. At that point, we'll multiply across. That'll give me the present value of the cash inflows. Then I remember, okay, well, it cost me $181,000 right now, today, to actually get this. So I do end up with positive NPV of almost $98,000. That's good. That's a good thing. All right. So if this were my only project, I would say, well, in this case, NPV greater than 0, invest. This would be my decision. But this is not my only project, right? In this case, we've actually got another project we have to consider also. And because of that, we're not sure if we can say that just yet, right? That may be right. That may be the decision we come to. But right now, we can't definitively say this is the project we want to invest in just because it has positive NPV. The other project might have positive NPV also. and then we'll have to rank those out, and that's what profitability index is there for. So in this case, we would normally say to invest, but once again, when we've got two projects, it takes a little bit longer to get to that definitive point of saying for sure, this is the one we want to invest in. Now, what's nice about doing a problem like this, though, is notice, once you get these factors, all of your projects require the same 6% return. Both of these are 5-year projects. Those factors are the same. So the only thing you're changing is your cash inflows, which are given to you. You multiply that out, and then your actual cost, which is also already given to you. So once you understand how to get these factors, these net present value problems really aren't too bad. So here we go. In this case, go ahead and multiply all that out. And what you'll find is that you end up with $199,450. This is your present value of the cash inflows. Then you'll need to subtract out the present value of the cash outflows. Once again, that happened today, so there was no need to do any discounting. If you wanted to imagine it, it would be like this: 141,960 times 1 is 141,960, because that's just what it's worth today. There's no discounting happening because it's now, right now already. So we didn't need to do anything else to that. And that's why the present value of the outflow is so much easier, because you don't have to adjust it. Whereas the inflows, you are having to discount each one of those back. This gets you to net present value 57,490. And once again, if this was our only project, I'd say, all right, NPV greater than 0, invest. But you see the problem here. 57,000 is greater than 0, 98,000 is greater than 0. On their own, I would invest in both of them. So for example, if this is 2 mowers, you're going to need to pick. If this is, for example, a mower and a weed eater, invest, right? But if they're mutually exclusive, then you got a little bit more work to do. And that's what they ask us about in part 2. For each alternative, compute profitability index. Then if we can only pick one, which should we pick? So what we do for profitability index is we come in and we take the present value of the net cash flows and divide it by the investment. Now, I do want to point out something. Notice this is the net cash flows. And notice where this 279 is coming from. It's right here. It's the part before you subtract out the present value of the outflow. The reason that's so important is if your profitability index, let me erase this box, it's kind of in the way now. If your profitability index is greater than 1, this is normally something you could consider investing in, or it is something you should consider investing in. If your profitability index is less than 1, then don't invest. And that's because if your profitability index is greater than 1, that implies that your NPV is greater than 0. And we know by NPV, if NPV is greater than 0, we should invest. However, if profitability index is less than 1, it's less than 1 because of the implication that NPV is less than 0, or that NPV is negative. And so in this case, both of these are actually good projects, and that shouldn't be a surprise. That's what we found by NPV. They should lean in the same direction. What might happen here, though, is in this case, project A had a much larger net present value based on the fact that it generated, let's just go back and we can look at the real numbers here. It generated $98,000 worth of NPV as compared to project B, which only generated a little under $60,000, or about $58,000 in NPV. And so at this point, it looks like A is much better. But when we actually normalize these things based on how much it costs, look at how much closer that comparison is. Now, it does turn out in this case that A is still better, but man, that's a lot closer than it looks like on the other page. And you could certainly see how sometimes this will flip. And so what you'll find in this case is that of the two, you want the higher profitability index. And so you will go with project A. Okay, now number 7, our last problem. one more example of net present value, but here we're going to look at internal rate of return also. So I'm going to run through the net present value stuff fairly quickly with this one. We'll look at it. So Phoenix Company can invest in each of 3 cheese-making projects, C1, 2, and 3. Each project requires an initial investment of $312,000. So this is going to be the cost of all 3 of them, and would yield the following annual cash flows. Now, what I want you to notice, and this is why I like this problem so much, and why I'll probably always assign something like this forever, as long as I ever teach this class, is because notice they've all got the same cost, 312, and they've all got the same total cash flow over the life, 372. But does that mean that their NPVs are all equal? Are all equal? Is that something we can say? You say, well, they've all got the same cost and they've all got the same total cash flow. So I feel like they should all have the same net present value maybe. But that's actually not going to be right, because remember our compounding effect. The earlier I get the money, the more valuable it is. The later I get the money, the less valuable it is. So what that means is before I even touch this problem or get past just a very cursory overview, I have a pretty good ability to figure out which project I probably want to stay away from. And that's probably project number 1. Why? Over half the revenue comes in 3 years. But for the first 2, I get very little back, which means by the time I get this 196, it will be pretty heavily discounted. However, look at project 3. Right away, I get back about 60% of my investment, maybe. Let's see, 208 divided by 372, 56% of my investment. I get back within a year. That's pretty good. That's pretty good. Now, project 2 is kind of an even split, which means that I'm going to assume this will have my highest net present value, this will have my lowest, and this will probably be somewhere in the middle. That's my expectation going into this. Now we'll see if we did that correctly, if our logic was right by the end, to see if the numbers show all this out. But hopefully we can see that that is certainly something that we could do. So, and that'll help you make more sense of a result on your test to make sure that you don't make a silly mistake. So I'm going to go ahead, I'm going to start erasing a bunch of this just because it bothers me how it moves around the screen as we move the scrolling. It gets very confusing, but here we go. For the next piece, we're going to go ahead and look. Assume the company requires a 9% rate of return for our investments using NPV to determine which projects, if any, should be invested in. So for the first one, of course, these are all different numbers. So what I'm going to recommend, come in here, come down. You've got your 312,000 cost. You've got your 3 cash flow numbers, and we're told this is a 9% rate of return. Come into table B1, go over to 9, 0.91, 0.84, 0.77. Of course, keep all 4 decimals, but those are going to drop in. Multiply across, you get 302,000. Your present value of the outflow is 312. So you actually have a net present value. In this case, it is negative. That is negative. So you should not invest in this because this is less than 0. So it's a bad investment. Now, project 2, the way this table is set up, you're going to have to also use table B1 just because that's how the homework wants it done. But I'll show you the alternative way to do this also with table B3, because this is the first chance we've really had, and it's the last problem on the assignment. So I do want to make sure you understand how to use that table in case you want to use it to check something on a test, or maybe you get in another class and you're using the annuity table. So I want you to see how that would work. But in this case, we're going to go ahead and we're going to pull in those same 3 factors. So they're going to drop in, have your new cash flows, multiply all that out. You get 313,882. Cost you 312. So we're going to say, yes, we should invest at 1882 while small is greater than 0. Now, what you could have done instead is you could have come up here to table B3, the present value of an annuity of $1, come over to 9%, taken that 124,000 times, in this case, you're going to come down to row 3, 2.5313, and that will give you $313,881. So $313,881, it's off $1 from this because of some rounding issues. But that is how you would use the annuity table. And then you've only got to get one factor. So what that says is, whenever we use the annuity table, if I have the same amount each year, then I can say, okay, well, I just need one factor. And you'll notice that in year 3, every one of these numbers is less than 3. And it should be. Because if it were 3, that would indicate no discounting happening at all. And so you'll notice that in year 1, everything's less than 1. In year 2, everything's less than 2. In year 3, everything's less than 3. And it has to be, right? It has to be. And so that's how our annuity table is working. Now for project C3, this is the one that we expected to have the highest net present value. And so once again, we've got our same factors that we had before. Pull those back in from table B.1. You've got your cash inflows that are given to you. You'll multiply across. That'll give you your present value for each year. Add those up. That'll give you the present value of the inflows. Subtract out the initial outflow, and you get net present value of a positive about $12,000. So you should invest in project C3. So in the end, don't invest in C1. Do invest in C2 and C3. Okay, so with that, we'll go ahead, clear all that out, and hop on over to number 2. Number 2, using the answer from part 1, is the internal rate of return higher or lower than 9% for project C2? So they're not actually asking you to compute internal rate of return, which is nice, but they're asking you to determine if this is higher or not. So this is where we get into another illustration that I like. So imagine you have a track, and I'm going to try to draw this, but I'm not good at drawing normally with a pencil, so I can only imagine how bad this is about to be on a computer with a mouse. But you've got a track, and you've got some hurdles set up, and I'm just going to draw them kind of like pie, right? But you can imagine like you're running down the track this way, and you've got a hurdle ahead of you. And so if you are talented, which I am not at running track and jumping hurdles, but if you are, or if you at least know this example and you've seen a hurdle before, then this should help. What's going to happen if you are running down that track and you're like me and you jump, but you don't really have enough behind that jump to get over it? You're going to fall. You're going to hurt yourself. You're going to embarrass yourself. It's going to be a bad situation. Probably going to be something you don't want to repeat again, right? The reason I like this example of the hurdle is because whenever we're dealing with internal rate of return, we are comparing this to what is called the hurdle rate. The hurdle rate is the required rate of return for the company. In this case, that's 9%, evidently, right? The company requires a 9% return from our investments. So our hurdle rate is 9%. So if our project is going to generate a return of less than 9%, I want you to think of this like the person like myself running down the track who jumps and falls over the hurdle and hurts themselves, right? This is not something you want to do because it's not a fun experience. However, if your internal rate of return is greater than 9%, you're going to be one of those people that runs down the track and jumps beautifully over the hurdle and then continues on like nothing even happened, right? And you're just moving through it, no big deal. The issue here is, this is what we're looking for, is this relationship between the internal rate of return and the actual hurdle rate. So the internal rate of return in this case, if it is greater than 9%, we should invest. So now we think, well, do we have something that we could base that on? Oh, wait a minute, we have NPV. And we learned that NPV for project C2 was greater than 0, which told us we should invest. Well, if we should invest because of net present value, that should indicate to me that my internal rate of return must be greater than 9%. I don't know what it is. It could be 10%. It could be 11%. It could be 13.4%. I have no idea. I'm not asked to compute that here. What I am asked is, using my intuition, can I determine if that internal rate of return that I have is greater than 9? And I certainly can. So in this case, that's what we find, is we say, because project C2 was actually profitable by NPV, then we can say we actually do have an internal rate of return in excess of 9%. And so we should actually do this thing. And so if it helps you as you are kind of internalizing that picture, If you imagine like you running down the track are your internal rate of return, and the hurdle rate, of course, is the actual hurdle. Well, if your internal rate of return goes over the hurdle or is greater, then do the thing. If your internal rate of return is less than the hurdle rate, don't do the thing, right? You didn't jump high enough in that case. And so that is how you want to wrap up your thinking here on internal rate of return, or at least that's what's always made the most sense to me. And so hopefully that illustration helps you as well. So with that, we are officially done with our last homework assignment for Accounting 2302 for the semester. I know you are all heartbroken about the fact that you are now done with your accounting homework for the last time, but hopefully you've had a good time in the class, and I hope you continue your pursuit either in accounting or whatever it is. I hope you're always very successful in whatever you decide to do. So if you do have any questions, like always, feel free to reach out to me. Otherwise, have a great day. Thank you.